Welcome back to Common Core Algebra 2. Today's lesson is 3.2, Average Rate of Change. When we model using functions, we are very often interested in the rate that the output is changing compared to the rate of the input. This has a lot of application in real-world situations because we very often want to know how things are changing, usually in respect to time. So, taking a look at exercise 1, the function f of x is shown graphed to the right. I gave you a graph that you can use in your notes while you work on this problem, so you should either tape it or staple it into your notes at this point. So, evaluate f of 0. So if you take a look at our graph, I'm just going to slide this up a little bit. F of 0, right here, f of 0, when x is 0, y is 1. When f is 4, y is 7. When f is 7, y is 10. And when f is 13, y is 15. So basically they just represent the points 0, 1, 4, 7, 7, 10, and 13, 15 as illustrated on the graph. B says find the change in the function delta f over each of the following domain intervals. Find this both by subtraction and show this on the graph. So if you take a look, delta f is basically the change in the y values. So in this case, we have delta f is equal to, so 0 and 4, between 0, 1, 2, 3, 4, and 4. So between this point and this point, the y values are 7 and 1. So it's going to be 7 minus 1, which is 6. So basically what that means is from here to here, we have a change of 6. So between 4 and 7, we have a change. So between this point and this point, we have a change of 3. And between this point and this point, we have a change of 5. So this is 3, and this is 5. That was just an easier way to do it instead of counting. C. Why can't you simply compare the changes in f from part B to determine over which interval the function changes the fastest? Well, the domain intervals aren't always consistent. They're not the same. So it's kind of hard to use that to determine if which one is growing faster or which one is not growing faster. So for example, if you were trying to compare how fast trees were growing, and one tree you considered over how many weeks it grew, and another tree, let's say we looked at how many years it grew, because those x values aren't consistent, it doesn't make sense to be able to talk about, compare the changes from part B to determine over which interval the function is changing the fastest. So that's why we need to discuss the average rate of change. So let's move on to D. So you can pause the video and kind of use your own words to answer letter C there. D says, calculate the average rate of change for the function over each of the intervals and determine which interval has the greatest rate. So, we're simply going to do the change of f over the change of x. So, you guys know that because that is basically our slope function. Our change of f over our change of x, because the change of f is the change in the y. So, this is the same thing as the change in the y over the change in the x. So if we look at the first interval, the change of y over the change in x is equal to 6 over 4, which is equal to 3 over 2. You might want to pause and take a look at the graph and just verify that. The second one is 3 over 3, which is 1, and the last one is 5 over 6. So this one is the fastest, This one is the slowest, and the middle one is in the middle. So D says, using a straight edge, draw in the lines whose slope you found in part D by connecting the points shown on the graph. The average rate of change gives a measurement of what property of the line. So let's go back to our graph and draw in those. You're going to use a ruler. I'm going to do the best job I can to make them as straight as I can. So there is the slope of the first one. There's the slope of the second one. And there's the slope of the third one. Let me just remind you, this one was 3/2, up 3, over 2, up 3, over 2. This one was a slope of 1, because we went up 1, over 1, up 1, over 1, up 1, over 1. And the last one was 5 over 6, because we went up 5, 1, 2, 3, 4, 5, and over 6 to get to this one. So this one was up 3 over 2, up 3 over 2. So the question also says, the average rate of change gives a measurement of what property of the line? Well, basically, it measures the steepness of the line. So going back down here, we drew this. So the average rate of change measures the steepness of the line. And of course, in our equation, we know we refer to that as the slope of the line. Please make sure you're pausing and you are writing things down as we go. The average rate of change is an exceptionally important concept in mathematics because it gives us a way to quantify how fast a function changes on average over a certain domain interval. Although we used its formula in the last exercises, we state it formally here. So this is something that should really definitely be put into your notes, really definitely be put in your notes. Average rate of change. So for a function over a domain, over the interval, so x is sandwiched between a and b. All right, the function's average rate of change is calculated by the change in f over the change in x, which is the change in the output over the change in the input, which we say f of b minus f of a over b minus a. But this should look a little familiar to you because in Algebra 1, we used to say the change in y over the change in x is y2 minus y1 over x2 minus x1, given 2 points, x1, y1, and x2, y2. And it's the same thing. It's just using new function notation. It means the same thing. I'm just going to write here, slope formula. So in exercise 2, consider the two functions f of x equals 5x plus 7 and g of x equals, don't forget that squared there, it's kind of hiding, g of x equals 2x squared plus 1. So calculate the average rate of change for both functions over the following intervals. Do your work carefully and show the calculations that lead to your answers. So down here, we're going to need some space for this. So make sure you're not at the bottom of the page. So on this one, I'm going to do a little divider here. So the first thing I'm going to look at is f of x. Because this is telling me here, I have 2 points with x. Here I have -2, and I need to know what the y is. And here I have 3, and I also need to know what the y is. So f of x. So what we're going to do is we're going to say f of -2 is equal to 5 times -2 plus 7, which is equal to, once you do the math, -3. And then f of 3, which is the second half of our interval here, is 5 times 3 plus 7, which is equal to 22. So again, what I'm referring to are those points, -2, -3, and 3, 22. So now what we can do is we can calculate what our change in y over change in x is. So we're going to say change of f over change of x is equal to 22 minus a -3 over, remember, this minus this, this minus this, over 3 minus a -2. And once we simplify that, we get 25 over 5, which simplifies to 5. Now we have to do the same thing with g of x. I hope I have enough room. So g of x is equal to, goes to g of -2, same situation, which is 2 times -2 squared plus 1, which is equal to 9. So I know that point that we were just talking about up here was now going to be -2, positive 9. And we're going to do the same thing with our other interval, which is 3. So g of 3 is equal to 2 times 3 squared plus 1, which is equal to 19. 9 times 2 is 18. 18 plus 1 is 19. That's right. So we have 3 comma 19 being the other point. So now we can come down here and do the same thing and do our change of f over, change of g. Let's erase that so we don't confuse anybody. Change in g, which is basically a change in our y, over change in x, which is equal to 19 minus 9, this minus this, this minus this, divided by 3 minus -2, which reduces to 2. Okay? So now what I want you to do is I'd like you to take just a minute and pause the video and try doing the same thing on this side for our 1 and our 5. So you're going to do the same thing. You're going to come over here and you're going to calculate f of x for 1, and you're going to calculate g of x, f of x for 1 and f of x for 5. So you're going to figure out what f of 1 is and then what f of 5 is. And then you're going to come over here and you're going to do g of x, and you're going to do g of x for 1 and g of x for 5, and determine what the change of f and the change of g over x is. So use the left side as a model for you to finish what's going on the right. Hopefully you were able to follow that. I know it was a lot of busy work there, but you figured out how to find the average rate of change of both functions. Now, B says the average rate of change for F was the same for both 1 and 2, but it was not the same for G, and why is that? So basically what that's saying is if you take a look up here, you'll see how we have 5 here and we have 5 here. But when you move down to G, we have 2 here and we have 12 here. So the question is, why? Well, I'm really hoping that you look at this and say, well, of course, because f is a linear function. Its slope is going to remain the same. So basically, no matter what points I choose, the change in y over change in x, or the slope of the function, is going to remain constant. That's the definition of a linear function. And looking at G is let's just go back up here quick and take a look at G. G of x again, right here, is y equals 2x plus 1. It's a quadratic function. So we know in a quadratic function, at the bottom closest to the vertex, in this case, because x is the coefficient in front of the x is positive, it opens up. So at the bottom, at the minimum, it's going to grow a little slower, but as it gets to towards the top, it's going to grow much faster. So your average rate is going to change much more quickly the higher you get. So, in your own words, pause and write that in B. Exercise 3 says the table below represents a linear function, filling the missing entries. So I think the easiest thing to do here is they're saying it's a linear function, so we know that the slope needs to remain constant. So that I know that if we want to figure out the slope between one point and another, and if it confuses you in the table, you can write down a few of the points. We have positive 1, negative 5, and positive 5, positive 1. So this can become our x1, y1, and x2, y2. So to find the change in f over the change in x, it's simply going to be the y values, which is negative 5 minus 1 over 1 minus 5. So negative 5 minus 1 and 1 minus 5, just making sure that I'm consistent, which is negative 6 over negative 4, which reduces to 3 over 2. So basically what this means is every time the x increases by 2, the y increases by 3. So we know this is our slope. So using that, see if you can find our missing spots for here, here, and here. Okay, I think I have it straight now because the way I was doing it the first time just didn't seem to work nicely. I think this works better if I consider 2 points. So I chose 2 points. I chose 5 comma 1 and I chose 11 comma y. And I said the change in y over the change in x, and I said 1 minus y over 5 minus 11 equals 3 halves because I know this is my slope. So then simply I just cross multiplied, making sure to distribute the 2, and then you minus 2 from both sides, and then y is equal to 10. So instead of y here now, this can be 10. So now why don't you do the same thing and see if you can find the x here and then the y again for here.